Okay, this is the P4 paper from June 2023. It's question number 4. And as we can see, this is a vectors question. Vectors in 3D. We're going to be solving some geometric problems. We're going to be finding the vector equation of a line. But let's have a look at it. Let's make a start to it. So it says in the question, we've got these points A, B, and P here. A, B, and P. And it tells me that straight line L passes through A and B. A little bit later on, it says there's another point C on L, and then PC is going to be perpendicular to L. That's way too much information. I'm just going to do a quick diagram, and I'm going to say, right, what they said was then, let's draw out a set of axes, 3D, but I'm only going to do 2 of the dimensions, so I can't draw in 3D anyway, can we? And what they're telling me is that I've got a line L, and this line, let's just put it there, say for example, this line L is passing through a point A and passing through the point B. Okay, so if that's the start off point really to what I'm getting on with here, then if I want to find the vector equation of this line, the vector equation of a line, R equals A plus lambda B. There's lots of different ways of writing it, but if I say A plus lambda B, A is getting onto the line itself, so I could use that vector there, or I could use that vector there, but a vector to get onto the line, and then B is going up and down the line. So, given my situation, what I'm going to do first of all is I'm going to work out the vector AB, because that'll be the direction of my line L. So AB, if I have this situation here where this is little a and this is little b here, AB will be B minus A. We've got the information about those there. We know the position vectors 4, 8, 1 and 5, 6, 3 there. So B minus A is going to be, now you can do this as a column vector or you can do it as an IJK. I always find it easier to do it as a column vector here when I'm doing this. 5, 6, 3 minus 4, 8, 1 there. So that's going to give me the vector 1 minus 2, 1, 1 minus 2, 2, sorry, there. Whether you want to leave it like that or write that that's I minus 2j plus 2k, that's entirely up to you. So the equation for L then, equation for L, don't get confused between my A and B up here and the A and B I've got in the question. So the equation for L is going to be R equals, not using that pen, sorry, R equals A, which is any of the vectors, so it's either, I'm going to use 5, 6, 3, but I could use either one, 5i plus 6j plus 3k, plus lambda lots of now the direction vector, so I minus 2j plus 2k. We can write that in lots of different ways, obviously. There's multiple answers available for this. You don't have to have 5, 6, 3. You could have used 4, 8, 1, and you could have written this in terms of columns. You could write it in any other way, but I'm going to stick with that one for the time being as being the vector equation of my line. Okay, so that's part A done. What does part B then say? Part B says point C lies on L so that PC is perpendicular to L. So let's put point C on there now. So point C is on the line, and then this point P, which I've sort of ignored so far, I'm going to put it in here, maybe there now. What we're saying is that P is such that actually now that's perpendicular to the line L. Well, it's up to you how many of these lines you want to put in terms of your diagram, but I've got that situation now then for where PC is. And it says, so for part B, can we find coordinates of C? So if we want to find coordinates of C, what I'm going to do first of all is I'm going to work out what OC would be. Well, OC, so this is part B, OC is a point on the line. So if it's a point on the line, it can be represented by this equation. So I'm going to say OC is 5i plus 6j plus 3k plus lambda lots of I minus 2j plus 2k. Now I'm going to tidy that up and get it all in terms of i's and j's and k's. So that's 5i plus lambda I, I'm going to say is 5 plus lambda I. It's 6j minus 2 lambda j, so that's plus 6 minus 2 lambda j and plus 3 plus 2 lambda k here. So that's my OC. And in which case, PC then, just do this up here, PC, the vector PC will be minus P plus C, won't it? It'll be minus C plus P or C minus P. That's what I'm going to do. So PC is the vector C minus P here. So that's going to be the vector that we just had. In fact, I'm going to copy it down. That vector minus P, and P was 2i minus 2j plus k as we were looking at that. So I've now got a way of writing out PC. PC is going to be, leave you to tidy that all up, but I make it 3 plus lambda lots of I. I'll make it 8 minus 2 lambda j. And I make it 2 plus 2 lambda k. Now, what was the whole point about getting PC? Well, the one thing I know about PC, if PC is perpendicular to L, then what we can say is that PC dotted with L will equal 0. So let's make that clear to the examiner. I'm going to say PC dotted with L equals 0. And when I say dotted with L, I mean dotted with the direction of L. So PC dotted with, that's the I minus 2j plus 2k part, isn't it? That must equal 0. So 3 plus lambda, let's again put all this in, I can just keep copying it out each time, just save myself a little bit of time. So that one dotted with I minus 2j plus 2k works out to be equal to 0. So that's going to be multiplying the i's, 3 plus lambda, multiplying the j's together, minus 2 lots of 8 minus 2 lambda, and the coefficient of the k, 2 lots of 2 plus 2 lambda. All of that is equal to 0, so tidy that up. 3 plus lambda, minus 16 plus 4 lambda, plus 4 plus 4 lambda equals 0. Well, that gives me 9 lambda minus 9 equals 0. In other words, lambda is equal to 1. So if lambda is equal to 1, I can go back to OC, because that's what I was trying to work out. OC is then 5 plus 1 lots of I, it's 6 minus 2 lots of j, and it's 3 plus 2 lots of k. We're just putting lambda equals 1 into that, so OC works out to be 6i plus 4j plus 5k. Let's just check, did they want the vector OC or the coordinate? No, they wanted the coordinates of C. So let's just be careful about that. Coordinates of C then. So point C is 6, 4, 5. We've done a lot of work to get that. Let's not lose a mark for not answering the question properly. Okay, on to the last part then. Sorry, the penultimate part, part C, says P dash is a reflection of P in the line L. They do this quite a lot here. This is a standard sort of thing that they sometimes do. What we're saying is, if I consider that line down there, P dash is just going the other side, the same distance. So if I carried that on, there is a P dash here somewhere, so that this is the same distance that side as it is that side, and it's perpendicular, etc., etc. And we need to work out what P dash is going to be. Right, so I'm just going to quickly, don't think you necessarily need to sketch this diagram out, but I'm just going to do it quickly to say, really more to explain it again. So what we're saying is, at this stage, that I have my line that was going across there, and what we've got is basically a situation where I know I've got P here, and that's the point 2, -2, 1. I've got C, which is at the point 6, 4, 5, and I'm trying to work out P dash such that it's equal distance to the other side. So I do these really quick. I know you can do it with vectors, but I just simply say, okay, if I've got 2, -2, 1, which goes to 6, 4, 5, I'm then just going to go 6, 4, 5, goes to P dash. What have I done each time? Well, I've added 4 on there, so I need to add 4 onto my X value. I've added 6 on there, so I need to add 6 on to my Y value, and I've added 4 on there, so I need to add 4 onto my final value. Means that my new point is going to be 10, 10, 9. Now, do I want the point or do I want the vector? No, I want the coordinates. So, okay, that means that P dash is just going to be equal to 10, 10, 9. You might think that's an unusual sort of little technique there, but I've used that lots of times in other videos of mine. Go and have a look at them. They seem to like doing that when we're going through and doing these sorts of questions. So finally, hence find the length of PP dash and give that as a surd. So if I want the length of PP dash, if you think about it, it's simply the distance from that point to that point, and we've got both of those points there. So for part D, it's just the length of a straight line. The PP dash, the length of it is just going to be the square root of x2 minus x1 squared, y2 minus y1 squared, z2 minus z1 squared. I'm not even going to put those bits in. I'm just going to put the actual values we've got here. It's 10 minus 2 squared. It's 10 minus 2, so it's 10 plus 2 squared. And then it's 9 minus 1 squared. And if you work that all out, that works out to be square root of, what have we got there? 64, 144, and 64 again. Okay, that's root 272. Stick that into the calculator, and that comes out to be 4 root 17. Okay, so that's that vectors question done in full. Not the easiest questions to do. Always a good idea to sketch out some sort of diagram to help you along as you're going on with it. And hopefully that all makes sense to you.